You spend weeks building a training module. You deliver it to your team, and by the next day, they've forgotten almost everything. This happens because the material often looks like this: a wall of dense text on one side, a tiny disconnected diagram on the other, and a maze of navigation buttons. This diagram illustrates the physical limit of human working memory, the mental workspace where active learning happens. As you can see by the gauge on the table, it has a strict capacity. It can only hold about 4 to 7 pieces of information at a time. Now compare that small workspace to long-term memory. This is a massive, permanent filing cabinet where knowledge is organized into structures called schemas. Once information is successfully processed and filed here, those strict capacity limits no longer apply. But bad training materials flood that small working memory table all at once. The system overloads and information drops on the floor before it ever gets permanently filed away. Over the next few minutes, we will fix this. We'll take a messy slide and transform it into a clear lesson that your team can actually process and remember. Effective training requires engineering the presentation to work within the human brain's natural memory limits, rather than fighting against them. Step 1 is minimizing extraneous load. This is the wasted mental effort caused strictly by poor instructional design and confusing layouts. When you put a detailed diagram on one side of a slide and the explanation text on the other, the brain burns its limited working memory energy simply trying to figure out where to look. We solve this using a principle called spatial contiguity. You place relevant text directly next to the exact item it describes. This mockup demonstrates the first action. We strip away the unnecessary wall of text from the screen and move those detailed explanations to a separate off-screen participant guide. This leaves only the primary diagram centered in our workspace. Next, we take concise text labels and position them immediately adjacent to their corresponding visual parts on the diagram. You also need to avoid placing dense text on a screen while speaking entirely different, out-of-sync words over it. That creates active competition for working memory resources. By removing visual and structural friction, we stop wasting the learner's energy on decoding the format. They preserve all their mental focus for the actual lesson. Step 2 is managing intrinsic load. This is the natural, unavoidable difficulty and complexity of the subject matter itself. We are not deleting hard topics or diluting the material. We are simply making complex elements easier to digest. The primary tool for managing this complexity is chunking, grouping multiple interacting elements into logical categories. This diagram shows what high intrinsic load looks like. Handing someone a scattered, intimidating list of 50 distinct software features all at once overwhelms working memory. Watch how chunking fixes this. The scattered information sorts into 3 simple, visually distinct columns: adding, quoting, and closing. You can provide additional scaffolding by handing the learner a quick reference cheat sheet to use during complex technical tasks. Managing intrinsic load prevents the learner from panicking and shutting down when faced with a high volume of new, interacting elements. Step 3 is maximizing germane load. This is the productive, desirable mental effort a learner must expend to actually build long-term schemas. Training shouldn't be a completely frictionless presentation. Once the bad design is gone, we deliberately add good friction back in. We create this productive effort through active retrieval. This means inserting realistic scenarios, working through detailed case studies, and running simulations into the workflow. For example, we add a mandatory practice check to the end of our newly cleaned module. We give the learner a short, realistic scenario and a text box, prompting them to type out an explanation of why the procedure works. Prompting the learner to explain a concept in their own words physically forces the brain to bridge working memory and long-term memory. Without germane load, information simply evaporates. Productive struggle is the absolute requirement for true retention and understanding. This diagram compares our starting point with the final result. On the left, the cluttered original slide. On the right, the optimized module. We minimized bad design for clean labels, managed complexity by chunking into 3 folders, and maximized practice with a guided scenario box. These 3 actions form the foundational logic of cognitive load theory. It removes mental distractions and scaffolds difficult concepts, giving your team a direct path from initial confusion to long-term retention. Take one piece of your own problematic training material, run it through this